Panda better. Please. Yes, sir.
Hello. Sit down, everyone.
Yes.
Sit down, pause. Sit down, everyone. Why am I listening myself? Okay. Can you what? Keep the mouse up. ये क्या हो गया? Keep the mouse up. Okay. Where did we stop in the last class? How many questions we have done? We did 8. Anybody has a doubt in question 8? Anybody has any doubt in question 8? That's 9. What is question 9 in your book? When ox can apply a maximum force of 1000 Newton. Just open the control, go up, open the participants, and just mute it. Mute.
Sir.
Okay, is the value correct in your question? Why are you holding a bag? Everybody do the question in your notebook. Question number 9. Force of 1000 Newton, right?
Yes.
And it is taking part in a kart race and is able to pull the cart at a constant speed of 30 meters per second. While making it rest effort, calculate the power of ox. P is equal to F into V, right? What is this? 1000 into 30. This will be how much? 30,000 watt or 30 kilowatt. This is the answer. Then question 9 is done. Question 10. The power of motor is 40 kilowatt. So P is equal to 40 kilowatt. Is this correct? The value?
Yes.
Then you have what speed can the motor race? So we have to find V is equal to what? What else is given?
Force.
Force is given. So this is again similar question.
Yes.
20,000 newtons, right?
Yes.
So what is V? P by F.
Yeah.
P is equal to F. P is equal to P by F. So how much is this? P is 40 kilowatt, right? It is 40,000 watt. So this is 2 meters. Okay. So straight formula based question. Then next. Rajan exerts a force of 150 Newton in pulling a cart. So this is again the same thing. Calculate the power F into V. F into V. So many. So I'm skipping this question. So let's do question 12. How is this? A boy weighing 350 Newton. So given weight. So weight is basically force. How much is that? 350 Newton. So to climb upstairs, climb up 30 steps, each 20 centimeter high. So H is equal to how much is that? 30. 30 into 20. So 0.2 meter. This is 6 meter high. Right? And time is 1 minute. T is equal to 1 minute. It is 60 seconds. Calculate the work done and the power spent. So W is equal to F into H. How much is F? 350. 6. 6 by 33. It's 80 plus 21, right? This 2100 joules. Just check if the numbers are similar in your book also. Then power is W by T. 2100 divided by 60. So 6 3 are 80. This is the power. Like this, you can go on trying. Any other question you want me to do? Let's do question 13. So there are only 4 more questions. Let's do all of them. Question 13. What is it? It takes 20 seconds for person A. So TA is 20 seconds. MA is 50. But another person B of the same mass, MB is also 50 kg. And 15 seconds. Compare the work done. So, what is WA versus WB? What is WA? What is the work done? So here in this case, pairs में जा रहा है तो H is same, right? For both. H is same in both cases. Right? So therefore, WA will be equal to MA G H. WB will be equal to MB G H. Right? And MA is equal to MB. So दोनों same ही है. So therefore, WA by WB will be so this will all be cancelled. So this is 1 by 1 is to 1. 1 is to 1.
What if we use the formula?
Force is MAG and MBG is the force,
The force to be made,
which is MAG, right? MG. So you write 50 kg
into D.
10. 50 G is the weight, not 50. 50 kg is mass. 50 kg into G is weight.
So that would be 50 kg.
So you have to convert that, na? 50 kgf में करोगे, so you can't have H in meter. So that is a gravitational unit. You have to keep all the units same. So you have to write 500 Newton. But G is not given, so you just put G, whatever, it will get cancelled. Is everybody with me? Okay. So work is, so the first one is, so answer therefore is, therefore WA is 1 is yes. Right, given data, right? So okay. Admit. Admit. ये solution है यहाँ से given के बाद solution हो गया. So everybody write till here. Yes. How many questions you have in your book? 16. We did 16. Okay. When we did 16? Is it? Only 2 remaining, right?
The second part is there.
Power the chapter, no?
Yes.
Yes, yes.
With the power.
So what about power, right? Power P A on G PV. So P is WA upon TA divided by WP upon PV. This is equal to WA upon TA multiplied by PV upon WP. Right? Now WA by WB is 1. Okay? 1 by 1. PV is how much? This is 5 3s of 15. This is what we are getting. Okay. Therefore, it's time pass कर रहे हो क्या?
Sir, मैं तो इस
Write with me फटाफट. कर दो पूरा. 14. चलो. Now here weight is given. Now here force is given in terms of kgf, right? So a boy of weight, and then you have a girl. So W boy is equal to how much? 40 kg. And weight of girl is given as 20 kg. Okay? Climb to 15 steps each. So height is same in both cases. H is equal to 15 into 15 centimeter is 0.15 meter. 15 की बजाय 20 दिया है. Okay, and what about the weight?
30.
Girl is 30, boy is 40. Okay, this is what H. How many steps?
30 steps.
30 steps into 0.2. 30 steps and 2 meters, right? So,
6 meters.
this is 6 meters. H is same in both the cases. Then, so this is weight, right? So we will not write W because otherwise it will confuse with work done. So F. Weight is force. Okay, W is for work. Like here we did work. So then both का time कितना दिया हुआ है?
So that is FG.
Weight of girl, weight of boy. What is the time given in your book?
4 minutes. 4 minutes.
4 minutes for boy and for girl.
3 minutes for girl.
Okay. So now we have EG is 4 minutes. And E girl is 3 minutes. Minutes. Converted in seconds and 4 into 60. 3 into 60.
180 seconds.
4 seconds,
24. 180.
Okay, let's now slowly calculate, right? What is the first thing we have to find out? Work done. So solution. So W boy versus W girl. How much is this? FP X. FP is 40. So what is FP?
FP is
40.
43. 6. Divided by boy, girl is 30 G. 6. So G and 6 will get cancelled. So this is 4 is to 6. Okay, we're getting 4:3. And what is the second part? Power. So power of boy or power of how much is called WB upon TG into by WB. We got y into reciprocal. When you divide it will be reciprocal, right?
Sir, that W no.
It will be changing. Very good, Bilal. See what difference it has made to you. WB is, what is WB by WG? 4 by 3. And what is TG?
180.
180. ठीक है ना? W by G we got from 4:3. And now that's 4, 6, 0, 0 becomes 4, 6, 3, 6. So 1 is ठीक है? So power ratio is 1:3. Okay, everybody try question number 15. Man raises a box of mass 50 kg. And equal to 50 kg. Is the value correct? Mass 50, height 2 meter,
Yes.
2 meter, T 20 seconds.
Yes.
While another man raises the same box to same height in 50 seconds. ठीक है? So work done. So work done is going to be same in both the cases because same mass is lifted by the same height. So work done is same. So solution. W1 is equal to MGH in both cases is equal to W2. Who is whistling? Where is Krish? ठीक है, चलो क्वेश्चन करो. W1 is equal to MGH equal to W2. आ जाओ बोर्ड पे आ जाओ. आ जाओ. Compare the work done and power by that. चलो. नीचे सॉल्व कर. यहाँ करना. इवेंट डेटा है आगे मैं बता रहा हूँ. So what is W1? Therefore W1 is equal to M दिया हुआ है. MGH के टर्म्स में लिख दो. W1 is equal to 50 into G. G given है क्या?
Yes sir.
G is 10 to 10. H कितना है? 2. हाँ ये 100 into 200. 50 into 10 कितना हुआ? हाँ 500 into 1000. Yes. 2000 ना? अच्छा 1000. ठीक है ठीक. ठीक है और जूल J. इसका यूनिट क्या है? अरे आप तो ठीक है. So both work are 1000. तो compare करो. Therefore W1 by W2 will be 1:1. Write down. Divided by 1000 equal to 1:1. Okay, this is work. Similarly, so questions are not different. Similarly, compare the power. Power. बेटा के power करो ऐसे. ये question में दो part क्या दिया हुआ है? Compare the work done
by each
with power developed by each man. T1 कितना हुआ? T1 is equal to W1 upon T1. W upon T1. W1 upon T1. कितना है T1? 20. So W कितना 1000 by? ठीक से लिखो. डेढ़ा सीधे लिखो. सीधे लिखो सब बेटा. T1 is equal to W1 upon
T1.
कैपिटल T नहीं है, स्मॉल T लिखा है. 50 क्या? 50 बैट्स. 50 वर्ड करेक्ट है. ठीक है. नेक्स्ट P2 निकालो.
P2 भी है.
P2 में
21.
1000 डिवाइड बाय 20 वर्ड. ठीक है. ये हो खत्म हो गया. इसका कंपैरिजन निकालो. T1 by T2 कितना आएगा? देखो यही नीचे लिखो. T1 by therefore T1 upon T2. ठीक है. 50 by 2 से -2 आएगा. ठीक है. इसको बहुत जल्दी नहीं यहाँ पे पीछे तो सीटी हो जाता है. यहाँ पे फटाफट करके बात. ठीक है. और यहाँ पे कैसे करना है इसको? हर जगह कैपिटल टी लिख के गया है, स्मॉल टी. सो इम्प्रूव योर राइटिंग. ठीक है. आंसर शीट में ऐसे लिखोगे. दिखाओ नोटबुक लेके आओ. सबको अपने राइटिंग पे काम करना पड़ेगा. ठीक है. 10th में अगर तुमने टीचर को तकलीफ दिया मार्क्स उतने ही कम मिलेंगे. हाँ ठीक है. इतना तो अच्छा लिखा. हाँ ठीक है. Okay, shall we start next chapter?
Yes.
Anybody has any doubt? Next unit. Yeah, no part. किसी को कोई डाउट है? पार्ट 1 में पार्ट ए में तभी तो कंपेयर किया. कैलकुलेट है ना. कैलकुलेट करके ही कंपेयर करोगे. और किसी को कोई डाउट यहाँ तक? इसके द्वारा लास्ट क्लास में किया है. इसमें नहीं किया उसको होमवर्क किया ना. Next is unit D. Unit B में क्या है? Types of energy, right? Different forms of energy. Different forms of energy. We had written down what are the different forms of energy. 7. किसको खड़ा करो? सीटी को बजा लो. सिर्फ किसको तो बोलता हूँ. खड़ा हो जा. क्या हो गया? हाँ क्या? खड़े हो जा. अरे खड़े हो जा. क्या नाम है? हाँ? गिरीश. ग्रेट. अच्छा ग्रेट. ग्रेट. बताओ what are the different forms of energy? Wind energy, solar energy. So I'll say light. Okay. Wind और solar इसी से आता है. ठीक है ना. So primary form of energy बताना है खाली. Light हो गया. और क्या है? Heat. Are you Chris? Are you Chris? Are you Chris? Third is nuclear. Last time we have to go in. We have to go in the order. Chris नहीं है ना चुपचाप. Next is sound. ठीक है? जो जिस ऑर्डर में एनर्जी है वैसे लिखते हैं साउंड. और केमिकल. Why chemical? When we burn anything, पहले burn किया ना इलेक्ट्रिसिटी को बाद में. अभी इलेक्ट्रिसिटी. ये सीक्वेंस में याद रखो. ये क्या है? प्रिमिटिव फॉर्म है. ठीक है ना? इलेक्ट्रिसिटी. You understand what is primitive? Understand what is primitive? Primitive मतलब historical जो पहले से आ रहा है. ठीक है? These are the most basic form of energy. Primitive, right? Electricity के बाद क्या? Nuclear. 1, 2, 3, 4, 5. और कुछ नहीं है. मैकेनिकल में पहले होना चाहिए. Actually, electricity और nuclear last में होना चाहिए. ठीक है? Sound पहले. वो अब तुम समझ गए? कर सकते हो. ये सेवन बेसिक तुम्हारे बुक में 15-20 दिया हुआ है. ठीक है? वो इसी का वेरिएंट होगा किसी एक फॉर्म में. इसलिए फिर से अभी तो आ नहीं रहा था किसी क्या होता है. मैं तो सुना ही नहीं. ठीक है, नेक्स्ट अभी बड़ा करता हूँ. चलो खड़े हो जाओ. मैकेनिकल एनर्जी में क्या क्या आता है बताओ. आता तो है बट मैकेनिकल में क्या आता है? काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी. अब बताओ काइनेटिक क्या होता है, पोटेंशियल क्या होता है. ये सीखना है इस चैप्टर में. क्या सीखना है? सिर्फ यही सीखना है. बाकी कोई भी एनर्जी हमें नहीं सीखना, खाली कन्वर्जन देखना. ठीक है? इस चैप्टर में यू विल लर्न दीस टू एनर्जीज इन डिटेल. तो पहले पोटेंशियल एनर्जी पढ़ेंगे. पोटेंशियल एनर्जी इसका सिंबल क्या है? कैपिटल यू. कैपिटल यू. ठीक है? Now what is potential energy? Raise your hands. कौन बताएगा? बताओ. Okay. By virtue of its state of rest or change in position and shape or size. ठीक है? So it is the energy possessed by a body. Possessed by the body. By virtue of its change of position or configuration. ठीक है? ये लिख लो अभी. ये जो पोजीशन और कॉन्फ़िगरेशन. कॉन्फ़िगरेशन मतलब इट्स शेप. जैसे स्प्रिंग ऐसे ही रिलैक्स है तो उसमें कोई एनर्जी नहीं है, बट स्प्रिंग को अगर खींच दिया या कंप्रेस कर दिया तो कौन सी पोटेंशियल एनर्जी है? इलास्टिक पोटेंशियल. ठीक है? पोजीशन चेंज करने से कौन सी पोटेंशियल एनर्जी आती है? ग्रेविटेशनल पोटेंशियल. तो देयर आर टू types of potential energy. Yes.
Elastic.
So one is gravitational potential energy. बुक में बहुत कुछ दिया हुआ है, वो तुमको हायर क्लासेस में समझ आएगा. अभी सिर्फ इतना देखो. ग्रेविटेशनल पोटेंशियल एनर्जी ड्यू टू चेंज ऑफ पोजीशन. किसकी वजह से आता है? पोजीशन। तो ये ग्रेविटेशनल है, मतलब whenever you are lifting your body against gravity, ठीक है, समझो तुमने उसको एक हाइट h पे लेके चले और ये बॉडी का मास m है, तो अब यहाँ पे पहुंचने के बाद उसमें कितनी एनर्जी आ जाएगी? Whatever is the work done on it, जो वर्क किया वही बॉडी की एनर्जी होगी, पता है ना? Whenever you do work on the body, its energy increases. तो अभी हमने कितना वर्क किया? तो वर्क डन is equal to potential energy. ऐसे लिखते हैं, potential energy is equal to work done in lifting the body against gravity. Yes, तो वर्क डन कितना हो रहा है? फोर्स कितना लगेगा? कम से कम mg। कितना लिफ्ट किया? h। therefore u कितना हो गया? ग्रेविटेशनल पोटेंशियल एनर्जी का ये फॉर्म, ठीक है। तो जब बॉडी सरफेस करेगी कितना पोटेंशियल एनर्जी होगा क्रिश उसमें? जब बॉडी सरफेस करेगी, बॉडी जब सरफेस पे है तो उसकी पोटेंशियल एनर्जी क्या होगी? जीरो। क्यों? h जीरो है, इसलिए h क्या है? जीरो है ना ग्राउंड पे, ऊपर h जो भी वैल्यू होगी तो mgh हो जाएगी। फोर्स mg होता है हमेशा, किसी भी बॉडी का जिसका मास m है, एटलीस्ट तुमको उसके वेट, जितना उसका वेट है उतना फोर्स ऊपर लगाना होगा, तो ही बॉडी ऊपर जाएगी। ये तो हो गया तुम्हारा पोटेंशियल एनर्जी ड्यू टू चेंज ऑफ इट्स पोजीशन, बॉडी का पोजीशन, इट्स पोजीशन। क्या पोजीशन था पहले? पहले ग्राउंड था, लेट्स कॉल इट एज पोजीशन ए। अब क्या हो गया? पोजीशन बी। दो अलग अलग पोजीशन हो गई, पोजीशन चेंज हुआ ना इसका, इसके लिए इसमें क्या आया? एनर्जी आ गई, ठीक है। तो पोटेंशियल एनर्जी के लिए बॉडी का पोजीशन चेंज होना चाहिए अगेंस्ट सम फोर्स, तो ही आएगा। यहाँ पे फोर्स क्या लग रहा है? ग्रेविटी नीचे लग रहा है, एक्सेलरेशन ड्यू टू ग्रेविटी किधर लग रही है? नीचे हमेशा। और फोर्स हमारा किधर लग रहा है? ऊपर। फोर्स कितना है? कम से कम फोर्स कितना लगेगा? उसका जो वेट है उतना, तो ही बॉडी ऊपर जाएगी। किसी को डाउट है? क्या हो गया? क्या जोक है? क्या जोक है? फर्स्ट बेंच से पीछे जोक तुम्हें दिख रहा है? ठीक है, nothing significant. Next is potential energy. कौन सा वाला?
Elastic.
Elastic potential. Second type is elastic potential. Yes. To change of configuration. As in stretched or compressed spring. चेंज ऑफ कॉन्फ़िगरेशन कैसे हो गया? या फिर बाउंड टॉय में क्या करते हैं? तो वाइड करते हैं ना, जैसे कार, तुमने टॉय कार में पीछे करते हो, वो क्या हो जाता है? स्प्रिंग बाउंड हो जाती है। द मोमेंट यू रिलीज इट रन्स अहेड। तो किसकी वजह से होता है? बाउंड स्प्रिंग की वजह से, ठीक है। और बाउंड स्प्रिंग इन वॉचेस और टॉयज, ठीक है। ये सारा जो पोटेंशियल एनर्जी है वो कौन सा है? इलास्टिक पोटेंशियल एनर्जी, ठीक है। तो देखो एक एग्जांपल देख लेते हैं। लेट अस से यू हैव अ रिलैक्स स्प्रिंग लाइक दिस, ऐसा ग्राउंड पे पड़ा, उसके ऊपर तुमने क्या रखा है? बॉल रखी। लेट अस से देयर इज अ बॉल केप्ट ऑन इट, ठीक है। नाउ यू आर कंप्रेसिंग इट, अभी कैसा हो गया? तो तुमने क्या करा है? You have compressed it. Compressed string. इसमें पोटेंशियल एनर्जी है क्या? नहीं। क्यों? क्योंकि रिलैक्स है। So it has no potential energy. No potential energy. ठीक है? So this has potential energy. अभी इसमें बॉल तुमने रखी हुई है. Now when you release it, what happens?
It comes back to relaxed.
So it will come back to relaxed position. And the ball will be thrown up. So the potential energy of the spring will now get converted into kinetic energy. Ball or revolver also works in the same principle. The trigger is pulled back. The trigger is attached to the spring. When you release the trigger, the spring will hit the bullet ahead. That's how the bullet leaves the gun. Okay. Is the elastic potential energy of the spring. So ultimately, who is working? The person who is compressing the string. So now in this string, what you have? Compressed string has elastic potential energy. Understood? So whatever work was done on the spring to compress it, that is the elastic potential energy stored in the spring. So who does the work? This external agency. Now when the external agency releases the finger, then it is thrown out. Clear? Next is kinetic energy.
The energy possessed by the body due to its state of motion is called kinetic energy. It is denoted by the letter K. K equals to 1/2 mass into
So any question in potential energy first? So it is taught in your school, right?
Yes.
How many schools? Raise your hands. This chapter is completed. So you already knew about it, right?
Yes, sir.
Left side, left side. Even if it is done in your school, I'm sure your concept will get better. So right now, you're not writing. You will not be able to maintain after some time. So make a habit of writing everything. Can I clear the left side?
Yes, sir. Live example.
Live example. This can be very dangerous. Don't keep it close to your eyes or your friend's eyes. ठीक है? अभी देखो. ये अगर दबाओगे पहले दब नहीं रहा. Put a ripple inside. There is ripple. तो ये क्या हो गया? ठीक है. तो इसको the good thing is to stretch it and leave. ठीक है? ऐसा. हाँ कोई भी इलास्टिक कुछ भी. Okay. Now see. अब ये
ज्यादा है।
गट स्टक
अरे बाप
हो गया यार, ये खाता हूँ जैसे देखा हमने, देखो अगर तो उसको दबा के छोड़ोगे और अगर ये हमारा एक्सपेरिमेंट सही रहा, ये तो जान नहीं है इसमें। दूसरा स्प्रिंग, दिस स्प्रिंग इज टू वीक। रिबिल में जाना लेट्स सी। This is not powerful. दम नहीं, ये रिवॉल्वर में नहीं चलेगा, रिवॉल्वर में काफी स्ट्रॉन्ग। ये किसका पेन है? देखो ये अभी दबाया था, उसमें पोटेंशियल एनर्जी स्टोर्ड है। अब इसको रिलीज करेंगे तो पेन को क्या करेगा? पीछे पे, ठीक है ना? ये ट्रिगर प्रेस किया तो अटक जाएगा, दोबारा रिलीज हो जाएगा। So do not play with stretched rubber band. Stretched rubber band can really hurt, right? Bow and arrow. So when you stretch the string of the bow, there is elastic potential. When you release, the arrow goes. Where does the arrow get kinetic energy from? Potential energy stored in the elastic. Okay. Now. Next is kinetic. What is the symbol? A. So he gave a very correct explanation. It is the energy possessed by the body by virtue of
State of motion.
state of motion. ठीक है? What does it mean? Any moving body has kinetic energy. So that is why you should not come in front of a moving cricket ball. So it will transfer full energy when it hits you. So when energy is transferred, then what will happen? What will happen? You're coming ahead. Far behind. हाँ, कैच करेगा तो ठीक है, क्योंकि वहां पे क्या चल रहा है? कैच करते टाइम which law is at play? Third law. What work is done? Change in momentum. Rate of change of momentum. ठीक है, force लगा रहा है ना, लेकिन which, my question was what work Bilal is doing? Positive or negative? Sir, negative. This, okay, everybody, this ball is going towards Bilal with velocity v, right? So when Bilal catches it, right? So what will Bilal do? He will hold the ball and pull the hand backwards. So till here, between position A and B, right? अगर बिलाल वहीं अड़ के ऐसे पकड़ रहा है बॉल को कैसे पकड़ रहा है? उसको लगेगा चोट, ठीक है? वैसे और अगर बॉल तो क्यों चोट लगेगी? चेंज ऑफ मोमेंटम के लिए टाइम कितना मिला? बहुत थोड़ा सा। तो फोर्स कितना जनरेट किया बॉल ने? डेल्टा पी डिवाइड बाय डेल्टा टी। अगर डेल्टा टी 0 है तो फोर्स कितना हो जाएगा? फोर्स बहुत बड़ा फोर्स लगेगा। तो तुम्हें क्या करना है? टी को बढ़ाना है, टाइम ड्यूरेशन को। तो टाइम ड्यूरेशन कैसे बढ़ा? यहाँ से। तो अब बॉल आ रही है, लुक हियर, ऐसे ही किया उसने। अभी आवाज आई क्या? और इट इज सो स्मूथ, आवाज भी नहीं आएगी। So what you did, you increase the time. So the impact is reduced. It's like if you have a hard close, किसी को उठा के पटक दिया, ठीक है? तो उसको टाइम मिला क्या? उसका मोमेंटम कैसे चेंज? रेट ऑफ चेंज ऑफ मोमेंटम. मोमेंटम सडनली चेंज हुआ. मोमेंटम सडनली चेंज हुआ मतलब टाइम ड्यूरेशन 0 है. मतलब फोर्स जनरेशन कितना हुआ? इम्पैक्ट कितना हुआ? इनफाइनाइट, हेवी. That's why if anybody jumps on the hard floor, finish. But if it was a cardboard या फिर sand रखा हुआ है, cardboard रखा है उसके ऊपर फेंका तो यहाँ पे गिरा, then the time is increased before it finally comes to stop.
That's why athletes also use sand to jump.
Yes, exactly. Sand, sponge, sand और sponge से क्या हो जाता है? You get heavy. You're stopping your momentum. Your velocity becomes 0 at point B, not right. Understand? So this is second law with respect to force generated. No. Second law, in the same situation, all laws are working. Listen, in the same situation, all laws are at work. Depends what are you asked to answer. Now, when you are calculating the impact or force generated, it is second law. But when you are asked, what work is he doing? Negative work. Why? Because if this agency is stopping, the force applied is in this direction. Whereas this is the displacement, AB. So work done is negative. And there is a question in your book. Daily question में ये है. When somebody is holding the ball, what work is he doing? Okay? तो ये सारा तुम्हें समझ के आंसर करना है. Work is negative because force is opposite to the motion of the ball. Right? But still, for some time, ball is moving against the direction of force. That's why it is negative work. Who is doing negative work? Or whosoever is catching the ball. ठीक है, catching the ball. Okay. ये समझ में आया? Why delta T is so important?
Yes, sir.
Right? Okay, so it is the energy possessed by a body by virtue of its state of motion. ठीक है? So therefore, that's why you should not come in front of a moving train. Moving train has so much energy, it will finish you off without even giving you a second chance, right? Truck, car, इसके सामने क्या करना है? Or a raging bull, or your friend. All of them have. So, is it that you have to be like careful about the moving body only? What if you run and hit the wall? क्या होगा? So what will happen? Rate of change of momentum very fast. You'll get a tight impact. Tight slap or whatever. Okay. So next. How do you calculate K? What is the? We say kinetic energy is this. How does a body get energy? When you work on it, so there are two ways to calculate it, right? Expression for kinetic energy. Kinetic energy. देखो, consider the body is at rest. Consider a body of mass m. Initially at rest. ठीक है? Initially at rest. That is क्या हो जाएगा? That is U is equal to 0. ठीक है? ये body है. ठीक है? Of mass m. And its U is equal to 0. Let's say a football, right? Football है, ठीक है? What are we saying? You have a football, उसका mass कितना है? M, and initially it is at rest. Now you kick it, ठीक है? तो अब क्या हो गया? When you kick it, right? So you apply some force on it. उसकी वजह से क्या होगा? Now it will, let's say it reaches here, right? या फिर तुम उसको धक्का दे रहे हो थोड़ी देर तक और छोड़ रहे हो. Imagine it is some object and you are pushing it and leaving. So you pushed it till here. Till what displacement you pushed it? Till here. You applied force on the body over displacement s. Now it has a velocity. तो छोड़ दिया. धक्का देकर छोड़ दो तो दौड़ता रहेगा. So it has now velocity v. So what did you do? You work on it so that it acquired velocity v. Okay? So whatever work is done in this process, that work will be its kinetic energy because work is energy, right? So kinetic energy is equal to work done on the body such that it acquires velocity v. ठीक है, पहले रेस्ट पे था, अब क्या हो गया, उसको वेलोसिटी v आ गया. ठीक है, let's see what is the case here. अब देखो, whenever you apply force on any body, its velocity is changing, state of motion is changing, मतलब उसमें क्या आएगा, acceleration आएगा. अगर accelerate होगा तभी तो उसको velocity आएगी, velocity, right? So therefore, find out what is the displacement now. So what is the work done? Therefore, kinetic energy K is equal to what is the work done? Force into displacement. Force is mass into acceleration. How much is S? S is U square minus V square. Oh, sorry. V square minus U square minus U square upon 2A. Correct? V होगा. But U कितना है? U is 0. So this is MA. So A MA square MV square by 2. This is the kinetic energy. So I prefer this derivation. In your book, there is a different method given. So second method, alternately. Your book method. What is the energy possessed by a body? Work done in stopping a moving body. The reverse case, there is a body which is moving. Now you worked on it or applied force in opposite direction to stop it. Okay? So उसका diagram कैसे बनेगा? You have now you have E, right? The body came here while you tried to stop it. Let us say travel. How much this? Yeah, displacement. This much. All this while you applied a force F on it. Okay. So what is the angle between F and S? F is in opposite direction to S. 180. So what is the work done? So K is equal to work done in stopping the body. Stopping the body. What is work done? F to S into cos 180.
Minus. So
Okay. So, but what is F? F is M into minus A into S into minus 1. ये भी M ही आ रहा है. And this is the and S. ठीक है? M A S ही आ रहा है. But S क्या आ गया इस केस में? K is equal to M A. S is now final velocity is 0. In this case, now V is equal to 0. Okay? Final velocity is 0. And here U, initial velocity is V. Got it?
yes, sir.
What is the situation here? Initial velocity is V and final velocity is 0. So let's start with 0 square minus V square. Right? Upon 2 and A was negative. S के लिए भी A क्या है? Retardation है ना? यहाँ पे भी A minus का ये सब M आ गया. अभी इस केस में क्या आ गया? MA minus V square upon minus 2A. A भी क्या? A भी half MV square. बुक के स्टेप समझ नहीं आते, ये लिख लो जिसको भी चाहिए। बुक का स्टेप काफी जनरली, बिकॉज दे हैव नॉट टेकन इनटू और इसलिए तो ये डायरेक्टली एमए लिखा है और बोल रहा है रिटार्डेशन, तो ये कैसे लिखा है? इसलिए लिख लो ये स्टेप। दिस विल हेल्प यू अंडरस्टैंड योर बुक बेटर। आ सकता है काइनेटिक एनर्जी का आ सकता है, क्योंकि इसमें सिर्फ काइनेटिक और पोटेंशियल एनर्जी। मैं एक्चुअली बुलाने वाला था, ये बिलाल है, पहचान यही करोड़ लास्ट वार्निंग। So, are you aware that you are all being watched by counselors on the camera? Are you aware or no? ठीक है, ये तो दिख रहा है क्या कर रहे हैं आप, और वो there is somebody who is watching everybody. Okay? Let me help them watch more people. So they can zoom and observe carefully. नहीं है ना, इसलिए तो बोला लिखो, तो लोग सुनते हैं बाद में कंफ्यूज हो जाएंगे पढ़ने के बाद, इसलिए मैंने बोला few things are not given very clearly. I have written it with the signs. So last part is, what is mechanical energy now? What is mechanical energy of the body? Mechanical energy of the body is sum of its potential and kinetic energy at any given instant. Okay, of a body is sum of its potential energy and kinetic energy at any given instant. That is E, mechanical energy E is equal to K U plus K or K plus. ठीक है, so mechanical energy is sum of K plus कुछ भी लिख सकते हो, you should be able to justify clearly. ये भी लिख सकते हो, वो भी लिख सकते हो, जो भी तुम्हें सिंपल लगता है, लेकिन वैसे ही लिखना है जैसे मैंने लिखा है। Consider a body of mass and initially at rest. ठीक है, now कुछ नहीं लिखा, मैंने सीधा डायग्राम बना। Now when a force is applied on the body such that it reaches velocity v, ये भी लिखना है, ठीक है। So then kinetic energy is worked on the body such that it हाँ लिखा तो है, ठीक है, and then as it does, yeah, you can write it whatever I have written there, और ये both are same thing। एक सिचुएशन में बॉडी रेस्ट पे है, उसको हम v वेलोसिटी पे लेके आए, दूसरे में there is a body which is moving with this velocity, now we stop and brought it to rest, just the reverse case of first case, दोनों करेक्ट। Shall I erase the website?
Yes.
Now, that's the book. So we covered gravitational potential energy at a height. Then, so we can. I'll ask you a question now. This is ground. Okay. This is height h1. And this is height h2 from. Which is greater? H2 is greater. So this is the initial height. Let's say some object not here. Then it was taken at this height. And it was taken at this height. Same option. So let's call this position as A, B, and C. Now, question. UA, UB, UC equal to 1. Okay. Second. What is the work done in taking body from within B position C? Everybody doing your notebook? Say UP is potential energies and respective equations. What's it? What's on that? What's it? Davies, don't send the right? So read the question properly. UC is not correct. Second part is correct. You have done it? Clear. So what's your name?
Gauri.
Gauri has done it. So three of them have done so far. Anybody else? Who else has done it? So let me note again. First part, first part is correct. Who else has done it? Raise your hands. So far, Gauri, Pratham, Divesh, you have done. What's your name? Shreya. Good. So many of you are getting that. Second is correct. You did first after second. What is the B? B is benchmark. Okay, take a little bit on the board. Okay, so I think most of you are getting it. Okay, good, good. So many of you have got it right. So what is UA? UA is mg into h. This is the potential energy, right? mg h and a. mg 0. UA is 0. Okay. What is UB? mg h1. So, and what is UC? mg h2. What is the second question? So work done in taking the body from here to here, right? So here body already had some energy.
Yes, sir.
So differential energy. Okay. So what is W is equal to UC minus UB. Okay, the difference of energy, that is the work done. Because it got additional energy, here it had energy UB. It got additional energy, some delta I, so that it became UC. Got it? Some additional energy. So the energy difference is UC minus UB. So mg H2 minus mg H1. मैं कुछ नहीं करूंगा, बाहर से बुलाऊंगा, ठीक है? और तो बाहर हो जाएगा. So how many of you got it? Raise your hands. ठीक है, चलो, good. Next. नहीं. Work energy theorem, is it taught in the school?
Yes, sir.
है? It's taught in the school. So देखो. So how will you get work energy theorem? Initial velocity of the U is not zero.
Yes.
Second case, right? So suppose we have a body. What is work energy theorem? Work energy theorem. It says work done on a body appears as change of its kinetic energy. Okay. So what is change of kinetic energy? Final kinetic energy minus initial kinetic energy. Half mv square minus half mv square. So whenever you work on a body, its kinetic energy will change. ये है work energy theorem. ठीक है? कैसे निकालना है? देखो, suppose you had a body initially of mass m, initially moving with velocity u. Now u is not zero. And when a force is applied on it, difference. Final minus initial. K final minus K. Now what is happening? Let us say it traveled displacement S when the force was acting on it, and now it acquired velocity V. So therefore, what is work done? Therefore, work done is equal to force into S. What did we say? Work energy theorem. So when we did work on this body which was initially moving with you, मतलब कोई दौड़ रहा है उसके पीछे तो और किसी ने धक्का दे दिया, तो उसका क्या हो गया? स्पीड ज्यादा हो गई. So what is force? Mass into acceleration. S कितना आ गया अभी? G square minus U square upon 2a. Okay, force लगाएगा तो इसमें क्या आ जाएगा? Acceleration आ जाएगा. So this is now half m v square आ गया.
V square minus
half m
half m
आ गया. Right here. What do you want me to explain? MX into it. What is force? Mass into acceleration. Second law into displacement. Got from the third law of motion. Initially moving with u. Final is v. So v square is equal to u square plus 2s. So s is equal to
v square minus
वैसे है. Many of you are asking how this came. This came from law equation of motion. This gives you what? V square minus v square equal to 8s. Okay. S क्या आ जाएगा? V square minus v square upon 2h. So remember this in the form of v square minus v square upon 2h. ठीक है? ये तो ये पता होना चाहिए. This is our knowledge from 9th standard learning. ठीक है? So with this we are done with. Then we have different forms of kinetic energy. Like potentially, how many forms we learned? 2. Gravitational and elastic. There are different types of kinetic energy also depending upon what motions the body is making. So if the body is going straight line motion, then we call kinetic energy as translational. A straight line is also called as translational. When the body is rotating, then it has rotational kinetic energy, like a spinning top, or when Earth is revolving around Sun. So any rotating, or the wheel of the car, right? Now the wheel of the car has both the energy, rotational plus it is also going straight on the ground. So it has both rotational as well as translational kinetic energy. Okay. Then you have vibrational kinetic energy. Any vibrating body, like the string of the guitar, right? Any wire which is tied at both the ends, when you pluck it in the middle, it will start vibrating. So any vibrating body has vibrational kinetic energy. Like this is right now hanging. Does it have any vibrational kinetic energy? Now we set it in oscillation. Now it has vibrational kinetic energy. Okay? Got it? So, or if you have a cantilever, you know cantilever? Any, like you have this on swimming pool, like in Olympic swimming pools, you have the thing coming out, right? The platform coming out. When the swimmer travels on it, comes on the edge, it dips a little bit. Then the diving board, when he takes the jump,
Yes.
and then he got it. So he goes up because of the vibrational energy of the platform. So that platform vibration helps him achieve bigger height. Then he does the somersault, acrobats. Okay, you got it? So that is vibrational energy. So some examples are there. You might be asked to give an example of body in translational, body having translational kinetic energy. Which energy? Give me an example of a body possessing translational kinetic energy. Car is any body moving in a straight line. Even a freely falling body is a straight line. Correct. But the senses. Any freely falling body is also having what energy? Translational kinetic. Linear or okay. So likewise. Then give me an example of rotational kinetic energy. Fan, yes. Fan will have fan or wheel of a car, right? Any vibrational kinetic energy. So atoms in solid, again reading. So when you have any solid, right? Solid is made up of atoms placed in close vicinity. But these atoms are not silent, they are vibrating. Okay. So any substance which has atom, right? All the atoms are having vibrational kinetic. Okay? And pendulum, right? Clock pendulum that has vibrational kinetic. Right? What about the bridge? When you travel on the bridge, rope suspension bridge. The bridge, does it have vibrational kinetic energy?
Yes.
It has. So the ropes holding the bridge would have enough tension, right? Not to hold the bridge, yeah. If the vibrational energy is too much, it will throw the cars and people walking around, right? Hold it. Bola? Yeah, that's what we said. That time you busy. So the atoms not only vibrate like this, sometimes like if it is a gas, diatomic gas, that time they are dancing like this, plus they are rotating it like this. All dimensions. So what can you see? Like these are atoms. So they are in solid, like they are held together. So they are only having vibration. But in gases, they are free to do this. Okay, in all dimensions, right? So they will have not only vibration, they will also have rotational, translational. So it's difficult, right? Let us say these are going like this, but the axis is not fixed. Helical DNA movement, right? They are turning and they are also traveling. It's complicated. So when you see it in YouTube video, the animation, that's really complicated. And that's only between two atoms of a gas. What about so many? So you can just imagine, right? Chaos, it's chaos. So you have this table. Everybody take a minute to read it. So I think everything you'll understand. The difference between potential and kinetic energy. Do you have any question in any point? Yes, now. Read this table, see for yourself. What we are discussing, you figure it out. Difference between potential and kinetic energy. Everybody read. See if you have any doubt. Any doubt in this? Okay. Now let us done reading.
Yes, sir.
Any doubt? No. So with me, different forms of energy. What is the first form of energy? Even solar. So solar energy, everybody knows. What is solar energy? Sunlight carries solar energy. Where is it used? So basically, there are two things. Listen. There is a source of energy, and you need a device to be able to harness or capture that energy. Solar energy is available. That doesn't mean you will be able to use it. Just like since rainwater is happening, you can't drink all of it unless you store it, right? Again, rain happens and then it gets drained off. Likewise, energy is available everywhere, but you should know how to harness or capture that energy. To capture the energy, you require so many types of devices. So we will understand about the source and how to capture it. Okay, clear? So solar energy cannot be put to work directly because it is not in concentrated form. It is so diffused, right? So like you cannot cook chapati or your food directly under sunlight. Can you? You need either solar cooker or some device where you can concentrate that energy and use it. So how can you concentrate that energy? One is solar panels. Once you have solar panels, what can you do? You can have solar water heater. So every room has solar panel. You see that big. See that how that solar panel acquired. So देखो अभी कार के अंदर बैठते हो. Can you sit without AC on? No.
Yes,
so
sir.
it is a small space. So heat is always coming into the car. So it is trapped inside. Okay, but in the atmosphere it is dissipated because it is open air. So any closed container. So that is how the solar panel. What it does is it is painted black. So when the sunlight falls on the surface, all the sunlight is getting absorbed. Then you have copper wires running. So you have a cool tank. So slowly, what happens? Cold water stays down, and the hot water stays up. So in the tank, the cool water is coming down. It is becoming hot. Once it becomes hot, its density is less. So it will rise up. So in the tank, the cool water outlet is at the base of the tank because the tank is overhead. The base of the tank, like in the tank, half of the water will be cold, and the hot water will get deposited outward. And the outlet in the bathroom is given on the water area. Anomalous expansion of water. It is expansion. It is expansion of water. Anything which is heated expands. So anomalous उस case में नहीं है. Anomalous अलग है.
Yes, sir.
Anomalous is abnormal behavior.
Yes, sir.
You expect the density to rise, but it is not rising. It is contracting. That's only between 0 to 4. Anomalous is only between 0 to 4, not between. Yes. So we did that in 90. Everybody understood? So this is everybody is nodding their head, but I don't know how much they want. Solar furnace. What is solar furnace? You can use a big concave mirror like this, right? And keep the water at the focus of it. That water will start boiling and convert into steam. Now you can use steam That steam, if you give it to dynamo or turbine, so that can produce electricity for you. Okay, everybody pay attention here. There's a lot of chatting happening, mutual chatting going on. What am I explaining? The solar furnace. What is it? You have a big concave mirror, at the focus of which you have kept water. Let's say, kaise water karoge? There is a pipe through which water is running, right? So at the focus, so much of sunlight is concentrated. The moment water reaches the focus of it, it turns into steam. So one side is water, the other side is steam outlet. That steam is at very high pressure. So using that steam, you give it as an input to turbine. It will rotate the turbine, right? And therefore, electricity will be produced. So turbine में क्या कनेक्ट कर रहा हूँ? Dynamo or generator. ठीक है? So somebody who rotates the generator, what is rotating the generator now? Turbine. And how the turbine is getting steam? Due to solar furnace. Understood? Yes, sir. Now all of it is explained in your 9th standard, right? So we need not go into it again. Okay? What else you have? Solar cells. What solar cell does? Here street lights these days. Solar street light, what it does? Trap sunlight, converts it directly into electricity. So solar cell क्या करता है? Electricity में करता है. Next is heat energy. How is heat energy produced? You can burn the substance, or even light has heat energy. Okay? Heat energy is in form of radiation. Like if you burn, like what do you call a fire, right? Or some wood, you burn there. Even here, you will feel, or when you go into kitchen, right? Mom is cooking, even nearby when you stand, you will feel the warmth. That is reaching you through radiation. So heat energy is radiation energy. So every heat energy has capacity to do work. Isn't it? Like how? Heat energy has capacity to do work, right?
Yes.
Yes. Heat energy कैसे दिखाओगे? Steam. Steam has lot of heat. तो पहले steam engine होते थे कि नहीं? So that heat energy itself is converted into mechanical energy. So heat से हमें क्या मिला? Motion. Right? Even today, when you have automobiles, what do you do? What do? You burn petrol or diesel. So when you burn, what happens? Burning anything produces heat energy. That heat energy is responsible for mechanical motion of the automobile. Yeah, heat is basically the heat energy in steam is moving better. Okay. So there are so many things interrelated also. So you have to be able to clearly articulate. So light energy. Light energy, it is the form of energy in the presence of which other objects are seen. Okay, so visibility is due to light energy. How can you obtain it? Light, दिन में तो sun is there. In old days we had candles, okay, or lamps. So when you burn it, burning produces light as well as heat. Now chemical energy. What is chemical energy? You are familiar with exothermic reactions. Are you familiar with exothermic reaction? What is it? Whenever exothermic reaction is taking place, heat energy is produced. So when we are respirating, what is happening? Respirating, सांस ले रहे हैं, breathing. When we are breathing, so what kind of reaction is taking place? Your body is at 0 degree or has some temperature? You're warm, right? You're warm. So exothermic reaction is taking place. The way that stops, the day that stops, it's the day you say bye bye to the body. Right? Okay. So that's chemical or fuel energy. How do we get chemical energy? One example is photosynthesis. When the light is absorbed by plants, right? By photosynthesis, what will they do? They convert that light into chemical energy. And when we eat that food, that becomes chemical energy in us. So when we feel energetic, right, after eating food, it is that because of that calories or chemical energy, right, which is getting converted into heat. Okay. So chemical or fuel energy. So anything when you burn, during burning, the chemical energy is converted into heat and light. What is hydro energy? Hydro means water. Any moving liquid will have kinetic energy. That is the hydro energy. So that can be used to turbine, right? So once the falling water, so in the dam, what are we doing? Hello? What conversation is going on? So when a water is trapped or held behind the dam, what energy the water has?
Potential energy.
Potential energy. When you release the water, then it is moving with a high speed and it hits the rotor of turbine. Then the turbine rotates, and then what it does? It rotates the dynamo or generator. So hydroelectricity is produced, right? Generator is a device which produces electricity, but only when it is rotated. So how do we rotate? By natural means, falling water. Okay, so that's clean energy, but at a lot of cost, we do ecological disturbance, right? Approved settlements where the dam is. So hydro energy will resume.